This video is going to have a look at one of the more common mathematical questions come up in the physics GCSE, and that's on kinetic energy. So let's have a look at the formula and how we can use it. Now, this is my formula. Kinetic energy equals half the value of mass times velocity squared. And when you get this question, velocity squared should be the first thing you do by the rules of bid mass. So you calculate this, multiply it by the mass, and then divide it by 2. Now, that's quite straightforward if they give you the mass and the velocity, or the mass and the speed. It gets a little bit more tricky when they give you the kinetic energy and one of these two, and they ask you to find the other one. So let's just have a look at how we would go about rearranging that question, rearranging the equation to answer that question. The first one's to find mass. I'm just going to switch the formula around first of all. So it is half mv squared equals ek. Now, in this case, I want to move all of the stuff over to the right hand side except for the mass. So if I multiply it by 2 on this side and I multiply that side by 2, these two bits here cancel each other out, which means that 2 times the kinetic energy equals the mass times velocity squared. I'm then going to divide both sides by velocity squared, and that will cancel these two out, which will leave me with mass equals 2 times kinetic energy divided by velocity squared. And again, in this case, you'd calculate this first, and then this, and then divide this by this. So I would do this in 2 stages. I'd calculate, or 3 stages, that number 1, that number 2, and then divide that by that number 3. So 3 steps. Make each of those steps really clear, because if you make a mistake, then the examiner can see where you made that mistake. Right, the second one, however, is a little bit trickier. So I've got the same thing, half mv squared gives me my kinetic energy. And I'm going to do the same thing first of all, 2 times the kinetic energy, and that's 2 times half e. That's going to cancel those out, which gets rid of that. Once I've done that, I'm going to have to divide both sides by the mass. That's reasonably straightforward. Those two cancel each other out. But now I'm left with this pesky squaring. So v squared will equal 2 times the kinetic energy. So to do that, to get rid of it, I'm going to have to square root both sides. That's going to these two are going to cancel each other out, because the square root of a square is the same answer. So the square root of v squared will just be v. And then I'm going to get this. And I'm going to go about it the same way. I'm going to calculate what's in here first. So 2 times ek, divide that by the mass, and then square root that answer. And that will give me my value for v. However, let's just have a look at a practice question and how we'd go about approaching this question. So first thing I always do whenever I get a question like this is I highlight any numbers. Even before I read the question, if I've got numbers, they're going to ask me to use them. Then I'm going to start reading the question. So, determine the kinetic energy of a 625 kilogram roller coaster car that is moving with a speed of 18.3 meters per second. Now, I know therefore that I'm looking for kinetic energy because it says so in the question. I've got mass and I've got velocity. Now, my mass is 625 and my speed is 18.3. Because we're talking about a roller coaster, this is going to be a big number, right? So that's kind of my check at the end. If I got a big value, I know I'm probably right. Now, the kinetic energy, I don't know. So that's going to be the subject of my equation. So EK equals, and then I'm going to just plug the numbers in, half times mass, which is 625, times my speed squared, which is 18.3 squared. Now, if you plug that all into a calculator, you're going to come up with an answer that's very large, 104,653. So 104,653.125. Okay. What I would make sure I do is I would do this first, 18.3 squared times 625, and then divide that answer by 2. That will give me this. But this number, as we predicted, is very large. I need to make it a bit smaller. So the way I'm going to do that is to turn this into kilojoules and then divide by 1,000. So I put my decimal place there, and then I will round up. So this would actually give me 105 kilojoules, because this rounded would round this up. So it'd be 105 kilojoules.